Inverse functions. What are their properties and how do you find their equations?
Inverse functions are just the opposite of regular functions. X and y switch places, and likewise domain and range also swap. This is because the x and y are switching places. A regular function and an inverse function will actually undo each other, and a regular function is written as f of x, whereas an inverse function is written like this. If you want to say it, you would say the inverse of f. It looks like it's a negative exponent, but it's actually not. Similar to how sine theta, if you want to find the inverse of sine, you would write it like this, with that -1. It's the same idea. The important thing to note is that inverse functions are not always functions. Just because the original f of x is a function doesn't mean the inverse will be. Let's try a simple example. So if we were looking for the inverse of this linear function, x and y swap places. So instead of writing y, I'm going to write x equals 2, not x, 2y minus 3. Next, we just want to isolate y. So first start by moving the 3 over. So that would mean 2y equals x plus 3. Then I'm going to divide both sides by 2. That would mean y equals 1/2 x plus 3 over 2. Now let's plot both these lines. Let's plot the function like we normally would. We'd notice the y-intercept is going to be 0, -3, xy, and rise 2 over 1, because the slope's 2 over 1. That would give us 1, -1. Now that I have 2 points, I can just connect the dots, try to draw a straight line, and that's a good sketch of that function. Now to find the inverse function, which instead of writing y, I could actually have written the inverse of f, like so. And instead of just plotting it in the same way, I'm actually going to switch x and y. So instead of writing 0, -3, I'm going to write -3, 0. And instead of 1, -1, -1, 1. X and y switch places. This is helpful for both the equation and graphs. And just looking at this graph these two graphs right now, I see that they're actually symmetrical along the line y equals x. This is true for all inverse functions. Let's try a more difficult example. For this square root function, the principle is the same to find the inverse function. I swap x and y in my equation, and then I solve for y. I'm going to start by moving the 3 to the other side. That would mean x minus 3 equals this square root. Next, I want to get rid of the square root, and to do that, I'm going to square. And the square root cancel out. Then I'm going to move this 1/2 over, get it to the opposite side so that there's no more multiplication, and to do that I'm going to multiply by 2, because 2 over 2 is 1. So if I multiply by 2, I would have 2x minus 3 squared equals y plus 7. Then I'm going to move the 7 over. So to do that, I'm going to subtract 7. So that would mean y equals 2x minus 3 squared minus 7. This is my inverse, the equation for my inverse function. I could also, instead of writing y, write the inverse of f. So I'm quickly going to graph these functions. If you don't remember how to graph, I did do a previous video when I described this, how to graph transformed functions. So my first point on my square root function, which will look something like that, is -7, 3 dc. And then another point would be 1 and 5, if I plug in x is 1, I get y will be 5. Now I'm going to connect the dots. That's a good sketch. Next, for my inverse, I know I'm going to just switch the x and the y's. So my new point would be 3, negative 7. And 5, 1. Connect those dots. You can see it's still reflected along that line y equals x. And if I was to state domain and range, let's try it. For my function, I see that domain is defined as x is an element of all real numbers such that x is equal to or greater than negative 7. And for range, I would say range is y is an element of all real numbers such that y is equal to or greater than 3. As I said previously, domain and range just swap for the inverse function. So I would say for my inverse function, domain is x is an element of all real numbers such that, and I'm just going to rewrite the y part. But instead of writing y, write x. X is equal to or greater than 3. Let's make sure that's true. X is equal to or greater than 3. Yes, that makes sense. And for range, range is y is an element of all real numbers such that, and then I'll copy this one out, y is equal to or greater than negative 7. And we see that's true. Y is equal to or greater than negative 7.
Thanks for watching. See you in the next video.